My name's Aiden, and today I'm going to go over some very basic integration that you'll find in maybe kind of more basic calculus or AP Calc AB. So the first thing that you'll need to know is the antiderivative power rule is what it's called. Or I sometimes call it the reverse power rule. It is literally just the power rule for derivatives, but just the opposite of it. So whatever steps you do in the power rule, you just do them the reverse way in the reverse order. So in the power rule, what you would do is you would multiply your function of x by the exponent, and then you subtract one from the exponent. What you do instead is you add one to the exponent, and then you divide by the exponent. So it's the opposite order, and it's the opposite things. So you can see a few examples here. So very basic, x to the sixth, you add 1 to 6, you get x to the 7th, divide by the exponent, which is 7. And then you always, never forget it, the plus c. So 4 dx is just 4x, because there's a little x to the 0 right here. You add 1 to it, it's 4x to the 1 divided by 1, so just 4x. You can see a bunch of different examples here. And whether you put, like this 4, this could be outside or inside the integral, the integrand. You could put it outside or inside. So this 1/3 could be inside, it could be outside, wouldn't matter. So there's one exception to this power rule, which is where you have x to the negative 1. Because you have x to the negative 1, you would get x to the 0 over something. And that just wouldn't work because you no longer have a function of x. So the integral of x to the negative 1 or 1 over x is just ln of x. So that's the one exception. But yeah, otherwise the rule is pretty solid. So the next thing, which is very, very important, especially for Calc AB, is U-Substitution. So this is basically simplifying a more complex function when you're integrating into like a form where you can use the antiderivative power rule. You just make a substitution for a function, and then you can use the power rule for it. So in this first example, x sine of x squared, you can make x squared equal to u, in which case it'll be sine of u, and the derivative of x squared would be 2x dx. And you already have an x dx out here. So what you would do is you would put in a little 2 on the inside, like a little fake 2 right here, and then you put a 1/2 on the outside. So it's just multiplying by 1. So if it's 1/2 on the outside, 2x sine x squared dx, that's just 1/2 on the outside, sine of u du. And then you can just integrate this. This isn't even using the power rule. It's just integral of sine of x is just negative cosine of x. Or in this case, it's using u, and then plus c, whatever, and then you'd plug back in the x. So you can do it with this equation right here, which is useful for series, by the way, if you ever take Calc BC. So in this case, yeah, you would just plug in u for ln of x, and 1 over x is the derivative of ln of x, and yeah, there you go. That's useful for that. And it's important to note that solutions are consistent with the antiderivative power rule. Everything in calculus is consistent with itself. So in this case, you have like a polynomial here that you can easily integrate with the antiderivative power rule, but instead you can separate out, like kind of factor it a little bit, and then you can, because the derivative of x cubed is going to be something with an x squared, you can use U-Substitution to get an answer for this. This is way more complex, obviously, than the real thing, but this answer at the end here is consistent with if you just use the antiderivative power rule on this. So you can see that pretty clearly. Thank you, and I hope this helps.